Hi, good evening, everyone. In today's lecture, I'm going to take some questions on continuity beta, and this is going to be from ISI 2004 past year. Let's look into the question. Pehla question dekho. It says you need to go ahead and you need to find limit sin x by x to the power 1 by x square. अब ध्यान से समझना start करो बेटा. See, we know that sin theta by theta limit theta tends to 0 is 1. This is what we know. I don't have to prove this. You can just use this directly. Now look into your function. The function that is given to you, that function is y is equal to sin x by x to the power 1 by x square, to the power 1 by x square. This is not directly x by x form, sin x by x form. In this case, you have the power given to you. Power is 1 by x square. So how do I solve such questions? In such questions, the first thing that you will go ahead and do is that you will take log on both sides. Now, when you go ahead and when you take log on both sides, then you can use the property that log m to the power n will be n log m. So this power that you have right here, this power can come here. Ha, beta. So when you will go ahead and you will bring this 1 by x square here, you will get this 1 by x square here, and you will get ln y is equal to 1 by x square ln sin x by x. Right? Now, once you have gone ahead and done this much, I want to somehow bring this in the form of L'Hopital. ठीक है, मुझे इसको L'Hopital फॉर्म में लेकर आना जरूरी है. अगर ये 0 by 0 फॉर्म हुआ तो शायद मैं डिफरेंशिएट कर पाऊं. So when I want to go ahead and I want to solve this further, but just think about this. If I tell you 1 by a into b, can I simply write this as b divided by a? Simple. So what I can go ahead and do is that because this is 1 by x square into this, it means my x square is in the denominator. तो मैं इस x square को ना denominator में ले आती हूँ and I will get ln sin x by x divided by x square. Limit x tends to 0. Now I will go ahead and I will use that property. क्या property थी बच्चे हमारी? क्या property हमने अभी पढ़ी है? We have read the property that limit theta tends to 0, sin theta by theta is 1. Right? Sin theta by theta is 1. That is the property that I have gone ahead and I have taught you. So beta, if I am supposed to go ahead and bring limit here, what will happen in this case? I can clearly go ahead and see that I will get ln. This part beta, यहाँ पे मैंने limit लगा दी. Limit x tends to 0, sin x by x, and then here I have x square. So from here, I will get ln. ये पूरा चीज beta, it will become 1 upon x square. And ln1 is 0 and x tends to 0, so this is also 0. So what I see is that I am getting 0 by 0 form in this case. इस चीज को solve करके I am going ahead and I am getting a 0 by 0 form. Since I am getting a 0 by 0 form, when I solve this, I have got a 0 by 0 form. So what should I be doing? I should be using L'Hopital rule. That is exactly what I'm going to go ahead and do. I will go ahead and I will use the L'Hopital rule. But L'Hopital में क्या करते हैं, कैसे use करते हैं? You will differentiate the numerator and denominator separately. तो हमने numerator को अलग से differentiate किया और denominator को अलग से differentiate किया. Now just have a look here. My numerator is ln sin x by x. So if I have to differentiate the numerator, how will I do it? Differentiation of log will be 1 by sin x by x into, now I have to differentiate this part. So I have to use the quotient rule. So differentiation of the numerator into denominator as it is minus differentiation of the denominator into numerator as it is upon denominator whole square. Right, beta? तो ये वाला जो part है, this thing that is coming in my numerator, this part. Beta, iska differentiation will be this entire thing that I have written here. I can just simplify this. So, this is 1 divided by this thing. So this is going to be equal to x by sine x into cos x into x minus sine x upon x square. So I will just have 1x cancelled. And this is going to be x cos x minus sine x upon x cos x upon x sine x. Upon x sin x. हाँ बेटा, this is going to be the differentiation of your numerator. इस numerator का differentiation ये हो गया. And L'Hopital में we need to differentiate the numerator and denominator separately. So the differentiation of this x square, it is going to be 2x. So we have gone ahead and we have differentiated the numerator separately. This is the differentiation of the numerator. And we have differentiated the denominator separately. This is the differentiation of the denominator. Now, after this, I will get this thing. I have got this thing. Achha, now I am still applying limit to it. So I will still go ahead and say that, okay, limit x tends to 0, x cos x minus sine x upon 2x square sine x. फिर से मैंने इस पे limit लगा दी. But when I will apply limit to it, what am I going to go ahead and get? 0 minus sine 0 is 0 upon 2 into 0. So I will again get 0 by 0 form. मतलब मेरा अभी भी solution नहीं आया. I haven't been able to solve this. अब मुझे यहाँ पर कुछ करना पड़ेगा so that I don't have to continue doing the L'Hopital rule again and again and again. I don't want to do that. So what I can go ahead and do, I have to do one tricky step here. ध्यान से समझना. What I can go ahead and I can do is, I will just divide this with x and multiply this with x. When I will do this, I will get x cos x minus sine x upon 2x cube sine x by x. Limit x tends to 0. Clear हुआ बात? We know that this part at least will become 1. Whenever limit x tends to 0 is coming, you will go ahead and get 1 here, right? So what I am going ahead and doing is, I am just eliminating this part now because I know that this will become 1 and I can just work with the remaining. So with the remaining, I will be left up with x cos x minus sine x upon 2x cube. This is a very important step to ease out the process. You can go ahead and do such things. Okay. Again, beta, now if I just go ahead and put 0 yahan par, so I will get 0 minus 0 by 0. So I'm still getting 0 by 0 form only in this case. Because I'm getting 0 by 0 form, I will again apply the L'Hopital. So differentiation of the numerator alag se karoge or differentiation of the denominator beta alag se karenge. So what will be the differentiation of the denominator? 2x cube hai na? So differentiation of the denominator will be 6x square. So this is what I've applied here. Differentiation of the denominator will be 6x square. And now just go ahead and look into the numerator. But your numerator is x cos x minus sine x. So if I have to differentiate the numerator, I will have to use the product rule here. Idhar product rule lagega. So what will I get? I will get differentiation of first function, second as it is, plus first function as it is, differentiation of second function minus cos x. So I will get cos x plus x sine x minus cos x. And when I will just solve this, I will get x sine x. So the differentiation of the numerator has gone ahead and it has given me x sin x. And the denominator has given me 6x square. This is what has gone ahead and happened. Acha, yahan par, sorry, I just haven't put the negative sign with minus sign, right? This is what I have got. Now, but a 1x is getting cancelled. So I am getting this minus 1 by 6 sine x by x, limit x tends to 0. And we know that this will become 1. So I will get the answer as minus 1 by 6. What does this mean? देखो ये पूरा चीज जो हमने solve किया, we solved this entire thing for ln y. We are solving this entire thing for ln y. So it means that I can go ahead and I can say that my ln y will be minus 1 by 6. Now I can just take e. So this will mean that y will be e to the power minus 1 by 6. Y will be e to the power minus 1 by 6. And that will be the answer to this question. Answer will be D. E to the power minus 1 by 6. Okay, beta. Okay, come to the next question now. ISI 2004, another important question. देखो ध्यान से. You are given a function. And this function is of this format. You are given x to the power t minus 1 upon x to the power t plus 1. This is the function that is given to you, right? And it is asking you that is this function continuous or not? Or is it discontinuous or what is the thing? Right? This is what the question is asking. So just think about it. When is the function not continuous? When left hand limit, right hand limit, they are not equal to each other, right? And they're not equal to the value of the function. Then my function is discontinuous. Then my function is discontinuous. Now, if I just go ahead and I look in this function, ये जो मेरे को function यहाँ given है, अगर मैं इस function को ध्यान से देखती हूँ, I want to go ahead and I want to evaluate this function. It tells me that, so here it is given that x is between 0 and 1. So I want to go ahead and I want to evaluate this function between 0 and 1. This is what my aim is, right? Now let's just start processing. इसको एक बारी ध्यान से सोचना शुरू करते हैं. See, when I go ahead and when I tell you that your function x का जो value है, x is between 0 and 1. ठीक है, जैसे I tell you for example, x is half, या x is 1 by 3, या x is 1 by 4. It is a decimal. तो बेटा जैसे जैसे हम इसकी पावर बढ़ाएंगे, देखो अगर मैं x को half लेती हूँ, if I take x to be half, so what will be x square? It will be 1 by 4. What will be x cube? It will be 1 by 8. Right? What will be x to the power 4? It will be 1 by 16. So can you see that it is decreasing half, then 1 divided in 4 parts, 1 in 8 parts, 1 in 16 parts, and so on. It is falling. It is decreasing. So as the power will continuously increase, your value will keep decreasing and it will approach 0. It will become very, very close to 0. So when your value, when x is between 0 to 1, when x is between 0 to 1, we notice that x to the power t, beta, this is approaching 0. X to the power t is approaching 0. है ना? So it means that this part, तो अगर मैं इसको solve करूं, if I just go ahead and I take limit, I am approaching 1, but I have a value less than 1. And I just take x to the power t minus 1, x to the power t plus 1. So what do I notice? I notice that this value is falling, 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 and it is going towards 0. So I will notice that it will become 0 minus 1 upon 0 plus 1. That means minus 1 by 1. That means minus. So my function takes the value minus 1 if I am approaching 1 from any value less than 1. Now, what if I'm approaching 1 from any value equal to 1? So, beta, again, go back to the function and tell me something. What if the value of my function is exactly 1? Then what will happen? Well, in that case, if I put exactly 1 here, so I will get 1 to the power t minus 1, 1 to the power t plus 1. 1 to the power anything is just 1. So I will get 1 minus 1 upon 1 plus 1, 0 by 2. It means I will get 0. So the value of my function at 1 is 0. Beta, yahi se pata chal gaya that the function is not continuous. When I'm approaching 1 from the left-hand side, the value of my function is minus 1. And when I'm approaching the function from when my function is 0, when I'm evaluating the function at 0, then the value of the function is, at 1, the value of the function is 0. It means that the function has become discontinuous. So here till 1, I'm taking 0 and 1. When I'm approaching it towards 1, it is giving me minus 1. But exactly at 1, it is becoming 0. And what if I approach the function from any value greater than 1? So just take the value of x, say to be 1.5. And just keep taking its power. So beta, suppose I tell you, or just take x to be some number, say 2. So as my t approaches infinity, what will happen? I will get 2, 2 to the power 2, 2 to the power 4, 2 to the power 8, and so on. Power is increasing. So this number will just explode now. It will go towards infinity. So if I were to go ahead and ask you, what will happen to x to the power t? When your x is greater than 1, it will approach infinity. So if I were to just go back to my function and I were to put anything more than 1, I will get infinity minus 1 upon infinity plus 1. So I will get infinity by infinity form. So I will have to use L'Hopital. I will have to use L'Hopital. Now just think about this. If I were to go ahead and use L'Hopital beta, तो किसके respect में differentiate करेंगे? I am approaching t to infinity na. So the variable I will have here will be t. So if I differentiate the numerator, I am going to go ahead and get x to the power t ln x. And if I differentiate the denominator, I'm going to go ahead and get x to the power t ln x. So when you will go ahead and differentiate the numerator and denominator using L'Hopital, you will get the same number and therefore you will get the answer as 1. So what does it mean? That when I am approaching the function from any value greater than 1, it is going towards 1. So when it is approached from here, it is going towards minus 1, 0 and 1. So clearly the function is discontinuous. The function is not continuous. So the answer to this question is that the function is a discontinuous function. It is not continuous at 1 because the left-hand limit, this is limit, left-hand limit, right-hand limit, and the value of function at 1 are not equal to each other. ये तीनों values equal नहीं है. They are not equal to each other. Right? So that's the answer to this question. So I hope that these sessions are useful to you. In these sessions, the aim is that beta we go ahead and we do questions which will be useful for ISI, IIT and GATE. It is very important to understand that if you want to go for a good crowd, right? If you want to go at places where you want to meet good economists, right? And you want to have a higher level in economics, you want to approach and do PhD in economics, or you want to go ahead and you want to get very good placement opportunity, then believe me, the right places are IIT and ISI. Okay? You can go ahead and you can ask your seniors that ISI and IIT at current market scenario have the best placement opportunities. So it is the right time to target these two institutes and get into these two institutes, because they are the one that are going to go ahead and give you the best placement. And they're going to be on, they should be on top of the list if you're aiming to do masters in economics from India. Right, beta? Okay, thank you.